Hi, in this video we're going to be talking about trig integrals, in particular those with sine and cosines in them. Now there are a couple of mistakes in here, but I do catch them before we do finish each problem. So let's start by recalling the integral and derivative of sine and cosine. So the integral of sine is negative cosine, and the integral of cosine is positive sine. The derivative of sine is cosine, and the derivative of cosine is negative sine. So let's look at our first example. And in our first example, we're just going to be looking at sine squared of x, cosine of x. And to solve this, we already know how to do this. It's just a simple u substitution. But this is included because a lot of what we're going to be doing ends up just boiling down to a u substitution at the end. So we're going to let u equal the sine of x because it's our squared function. So that tells us that du is cosine of x. Plugging it back in, we get the integral of u squared du. And we take that integral, it's u cubed over 3 plus c. And remember, I don't care about u, I care about my x. So we replace u with sine of x, and we get 1/3 sine of x plus c as our final answer. For our next example, we're going to look at the integral of sine to the 5th of x dx. I put theta, but I go back to x's. It doesn't really matter, it's a dummy variable. For this problem, we're going to have to break up sine to the 5th. And in order to do that, we have to use the trig identity sine squared plus cosine squared equals 1. And that tells us that sine squared is equal to 1 minus cosine squared. So how do we break this up so we can actually work with it? Well, we're going to pull one sine out, and then we're going to have sine squared inside of our function. Now we can use the identity here, so we get sine of x times the quantity of 1 minus cosine squared of x, all squared. And now we can just use a u substitution, where u is equal to cosine of x, telling us that du is going to be equal to negative sine of x. Now we have a sine of x, but we don't have a negative. So let's just throw a negative in there. We're just multiplying by a constant. And what we do on the inside of the integral, we have to do on the outside with a constant. So we pull that negative to the outside. So we get negative integral of 1 minus u squared du. We can FOIL that out. So we get negative integral of 1 minus 2u squared plus u to the 4th du. And now it's just constant rule, power rule, power rule. And we get a really nice simple answer in terms of u. But we don't care what u is, we care what our function of x is. So we're just going to take u, which is equal to cosine of x, and substitute it back in. And we're also going to distribute that negative at the same time. So we get negative cosine plus 2/3 cosine cubed plus 1/5 cosine to the 5th. And we can never forget that plus c, because then we're giving one out of infinitely many answers, which are really no answers at all. In our next example, we're going to look at the integral of sine to the 6th cosine cubed. Now, a good trick to remember, and in general, when we integrate things where we have an even power and an odd power of sine or cosine, we're going to break up the odd power and just use a u substitution on the other one. So in our case, we're going to be breaking up the cosine. So when we split it up, we're going to get sine to the 6th of x times cosine squared of x times cosine of x dx. Now, we're just going to use our trig identity here, the Pythagorean identity, if I recall correctly, and we're going to change cosine squared to 1 minus sine squared, and we're going to keep that cosine x dx on the outside. Now here we're just going to let u equal sine of x. Du then is going to be cosine of x dx. And when we replace it, we're going to see that the bronze is a function of u, and the gold itself is just du altogether. So I wrote u, and right here I just corrected to a function of u. Now, when we replace that, we get u to the 6th times the quantity of 1 minus u squared du. Now let's distribute that u to the 6th. Then we get u to the 6th minus u to the 8th du. We just take its antiderivative. We don't need to integrate, we don't need to have anything with the integrand anymore. We can just integrate it right here. And we get 1/7 u to the 7th minus 1/9 u to the 9th plus c. No, pass me, it's not a du. Right? But remember, we don't care about u, we care about our x. So it is 1/7 sine to the 7th of x minus 1/9 sine to the 9th of x plus c. The next one we're going to be looking at is we're not going to have an even and an odd power. We're going to have an even and an even. So we're going to have to do something a little trickier here. We're going to have to use a different trig identity. And we're actually going to use the half angle identities. So the half angle formulas say, if I have sine squared of x, I can break that down into 1 minus cosine 2x over 2. And I can break down cosine squared to 1 plus cosine 2x over 2. So let's go ahead and break those up right inside the integral. So I was going to write sine, but we're going to fix that to 1 minus cosine 2x over 2. And we're going to multiply that by 1 plus cosine 2x over 2. Okay, so we can pull out a 1/4. Now I did make this mistake and I didn't correct it. So that 1/2 is actually 1/4, and everything's going to be off by a factor of 1/2. But I'll make sure to speak what actually is the correct answer. So what we have on the inside of the integrand is now 1 minus cosine 2x times 1 plus cosine 2x. And we can just go ahead and multiply that out. And it should be a familiar thing. It's actually the factored form of the difference of squares. So on the inside, it's 1 minus cosine squared of 2x dx. Now we can break that up into just the integral of 1 dx or dx and the integral of cosine squared of 2x. So on one side we just get x after we integrate, and on the other side we get something that we're going to half angle again. So when we do that, we get 1 plus cosine 4x over 2. We can pull that 2 out, and we'll just have the integral of 1 plus cosine 4x. So the integral of x is just, the integral of dx is just x. And to integrate cosine of 4x, we're going to make a small u substitution. And it's going to be 4x, the argument of cosine. And du is going to be 4 dx. So we're going to have to put a 4 in there and balance it out with a 1/4. And we can just pull that 1/4 on the outside because it's a constant. So when we do that, we end up getting the integral of cosine u. And when we integrate cosine u, it's just going to be sine of u. So we're cleaning up the left-hand side a little bit, cleaning up the right-hand side a little bit. And remember, we don't care what u is, so we're going to substitute 4x back in. And our final answer should be 1/8 x minus 1/32 sine of 4x plus c. And for those of you who are doing this on your own and then not actually listening to the video, I just wanted to write it out. So I factor out a 1/2 when it should have been 1/4. So everything is off by a factor of 1/2. And we should again have 1/8 x minus 1/32 sine 4x plus c. Thank you for watching. I hope this helps you in your calculus endeavors.